Hi guys, let's derive osmotic pressure, formula for osmotic pressure in terms of solutions. Alright, now we know PV is equal to nRT, which is as per gas law. Now here instead of P, pressure, we write it as pi to represent osmotic pressure. So pi V is equal to N2RT, and it was N, but here we mention it as N2 because as I've already mentioned, 2 is for solute. So here we are concerned with solute. Alright, so pi V is equal to N2 RT. So pi is equal to N2. I take V this side. I take V below N2. So pi is equal to N2 over V RT. Now N2 over V we know is the formula for molarity. So pi is equal to capital M RT. Now instead of capital M RT we can also write W2 over M2, that is N2, weight of solute over molecular weight of solute, and divided by volume. So divided by volume RT. Alright, where T is temperature and R is gas constant. Alright, so that's the formula derivation for osmotic pressure. Alright, now coming forward. Now I need to talk something about the modifications that has been done. We studied about colligative properties. Colligative properties are those properties where we don't find any chemical change. When we bring in certain changes, there are no chemical changes, but there are physical changes. Now the physical changes, or rather the colligative properties that we studied in solution chapter, was lowering of vapor pressure, elevation in boiling point, depression in melting point, and osmotic pressure. And the relevant formulae are this. Relevant formulae are these. Alright. Now these colligative properties were applicable for non-electrolytes. Non-electrolytes in the sense sugar, glucose, urea, which do not dissociate in solution. Alright. Now let's talk also about electrolytes. Now what happens in electrolytes? We have two types of molecules, one which dissociate and one which associate. Now we had seen in our earlier video, acetic acid when taken in benzene associates to form dimer. Now this dimer formation and all is obviously owing to hydrogen bonding and other dipolar effects. Alright, so that is association. What is dissociation? Dissociation is the property of electrolytes. For example, sodium chloride. As soon as we put sodium chloride in water, it dissociates into Na plus and Cl minus. So dissociation is the property by which the salt dissociates into cation and anion, or breaks up into cation and anion in solution. Alright, so the property changes. There's a slight modification which we have got to do when we are dealing with compound which dissociates, or rather electrolytes, and the compound which associates. Alright, now we also understood Van 't Hoff's factor. Having understood Van 't Hoff factor, we saw in my earlier video how Van 't Hoff factor was involved in both the cases. Let's understand what is scribbled over here. Having understood Van 't Hoff factor I, all formula derived for colligative properties are to be modified. Alright, so and why are these to be modified? It's purely because of Van 't Hoff factor. So now the formula gets to same is the formula. This part is all same, but we have got to multiply all those formulae with Van 't Hoff factor. So same is the formula, but only the thing is we have got to multiply it with Van 't Hoff factor I. Alright, this is just to bring to your just to revise your capabilities. Small m is for molality. This is the formula, and capital M is for molarity. And mind you, these M2s, capital M2s, these are molecular weight of solute. Alright, so this is a change, or rather this is the modification that we have got to bring in for whenever the compound is dissociative or associative. And if it is not dissociative or associative, it's not an electrolyte, then in that case we can use all this formulae without multiplication of I. All right. So while you are solving numericals, please be careful about what is the molecule given to you.